What's up, Algebra 1? Mr. Ford here with another homework tutorial. We're doing this live with 6th hour right now. This is 4.2.3, problems 60 through 65. Let's just jump right into it. The whole first page of this is all systems of equations problems. And the story problem in 62 is kind of rough. So we're going to go a little fast through the easier examples in problem 60. But even then, 60C and 61 have a couple of teaching examples that we're going to talk about for a minute also. So let's just jump into it. Question A, what you got to recognize here is this is a substitution system. You have x equals negative 2y minus 3. What that means is that we're going to take that and plug it into the bottom equation. 4y minus, in parentheses, negative 2y minus 3 equals 9. And again, I want you to recognize that these two equations are exactly the same. The only difference is we replaced x with the negative 2y minus 3. There's still a lot of things to think about here. We got to distribute that subtraction. And that's going to change both of the negatives inside of that parentheses into pluses. It'll be 4y plus 2y plus 3 equals 9. From here, it's pretty straightforward. You combine your like terms, you get 6y plus 3 equals 9. Subtract the 3 on both sides, and you get 6y equals 6. And if you divide the 6, you get the simple answer of y equals 1. Of course, the answer is not really what's important here. It's about the process to get there. And also, y equals 1 is not the answer. You need both x and y. Fortunately, with substitution, once you have the first number, the second one's usually really easy to get. You just take it and plug it into whatever equation you started off with. We're going to plug it right up there. We know that x is equal to negative 2 times 1 minus 3, because y is equal to 1. And that is just going to be negative 2 minus 3, which is negative 5. And so I suppose the final answer here is negative 5, 1. Moving right along. Sorry, guys, I know we're moving fast, but we have to move to the next thing. Question B. This is an elimination system, and what tells you that right away is the x and the negative x hanging out right there in front. We're going to add those two together and cancel out those x's right away. We're going to add everything. I recommend you put the plus sign down so you don't forget you're adding everything. 5y plus 2y is 7y. 8 plus negative 1 is 7. And again, if you divide by 7 on both sides, you get y equals 1 again. It was 1 in the last problem too, wasn't it? X was 1 in the last problem. No, y was 1. Doesn't matter. Now that you know that y is 1, you still have to find x, which takes a little more work with an elimination problem. You can use either of the original two problems. I would recommend the top one, though, because it doesn't have any negatives in it. And if you can avoid that, that's always good. I like to start by writing that problem again, just as it originally was. And let's just go ahead and plug in the 1 from the fact that y is equal to 1. Right there. X plus 5 times 1 equals 8, which gives us a pretty easy problem. X plus 5 equals 8. That means x has got to be 3. And so again, the final answer here, I suppose, is 3, 1. Just look how much work goes into that final answer and understand why I don't give credit out if all you have is the answer written down. It's not about that at all. Question C. One more time, we've got another substitution system. Y is equal to 2x plus 10, although I'm going to put a star on this problem because an interesting thing is about to happen with it. Maybe you already know what's going to happen. We're going to replace that y with 2x plus 10. We're going to take the top equation this time. 4x minus 2 times y equals 5. Again, we're replacing the y with 2x plus 10 because y is 2x plus 10. They're the same thing. After we do our distribution, I think you might start to see what makes this problem interesting. You got 4x minus 4x minus 20 equals 5. And look what's going to happen when you combine your like terms together. 4x minus 4x is actually just going to cancel out and be gone. It's 0x. And what you're left with is this fun equation. Negative 20 equals 5. Which is not true, by the way. Negative 20 is not the same thing as 5. And so the answer here is actually no solution. And I want to take a minute to talk about what's going on here. This is a little bit of a side note in this instructional video for homework, but we'll talk about it a lot in the next couple chapters we look at. Basically, when it comes down to two lines in a plane, there are 3 ways that can happen. Let's draw some pictures really quick. You don't need to draw these with me, just follow along. There are 3 ways that two lines can mess around with each other in a plane. The normal way is they just cross. They touch one time, in which case you have one solution, which is the case for pretty much every example we've seen today up until question C. However, it's very possible that two lines that are in a plane could be what are called parallel lines that never touch. And that's exactly what's happening in question C. This has no solution because those two lines never cross. So there's never going to be a place where x and y are the same thing. If you were to take the first equation in this problem and make it into slope-intercept form, you would get a slope of 2 and a y-intercept of not 10, which is another way to think about this, but that's probably a little too heady for today. The other way that two lines can interact in the plane is by actually being the exact same line, which is tough to draw because you're drawing the same line twice, but I try to use two different colors there. This is the case of infinite solutions, which we're going to look at right now in problem 161, or 461. So let's look at it. We have Jai who's solving this system of equations, and he's getting an interesting result. So let's help him solve it and see what we get too. This is another substitution system, so we're going to replace the y with negative 2x plus 5. So we have 2 times negative 2x plus 5 plus 4x equals 10. Again, we're taking the second equation here and rewriting it after substituting in the value for y of negative 2x plus 5. And if you're thinking ahead about this problem, you might notice the exact same thing happening here that happened in the previous problem. 2 times negative 2 is going to give you negative 4x. 2 times 5 is going to give you 10. Plus 4x equals 10. And then once again, look what's going to happen here. We have negative 4x plus 4x. They're going to cancel out again. They become 0x. But if you look at what's left over here, this time we got 10 equals 10, which is true. 10 is equal to 10. And this is the marker to you that the answer here is infinite solutions. So kind of taking the curious case of the preview problem, looking at no solution and infinite solution systems. Basically, if your x's all cancel out and you get just numbers, ask yourself, is it true or false? To further explain this, we're going to graph both these equations on this same set of axes, which gives us the chance to practice graphing. Let's start with graphing the first equation, y equals negative 2x plus 5. It's pretty easy to graph because all you got to do is graph the y-intercept of 5 right on the y-axis, and then use the slope of negative 2 to make the line happen. That means go to the right one, down 2, right one, down 2, right one, down 2, and find a bunch of other points that are on this line, and then you can make the line happen. Kind of like that. Again, this is the equation y equals negative 2x plus 5. It's kind of hard to graph the second equation, though, because it's not in slope-intercept form. It's actually in what we call standard form. 2y plus 4x equals 10. It would be easier to graph it if it were in slope-intercept form. So that's kind of what we're going to do. Let's write over here in this space 2y plus 4x equals 10. And what we're going to do is we're actually going to solve this equation for y. We're going to subtract the 4x from both sides. We're going to cancel the 4x out on the left side. And we're going to get 2y equals negative 4x plus 10. And one more step we got to do is divide the 2 out on both sides. And when we do that, the 2's cancel out, and we get y equals negative 2x plus 5. Which is interesting to us because that's the exact same equation of the other line that we just drew. And the whole point of this is to show you that these are just two equations for the exact same line. Both of our original equations from this problem, these are the same idea. They graph the exact same line. If you were to open up Desmos, like a bunch of kids in my third hour did, and actually type them in, you would only see one line happen, which is why infinite solutions happens when you try to solve it algebraically. We got more to say about these next week, but for the most part, they're preview questions. Let's move to 462. This is a story problem, and it's not a very easy story problem either, but it does follow the same pattern as all the other story problems, so we're going to write the equations together right now. On Tuesday, the cafeteria sold pizza slices and burritos. Let's go ahead and put P and B down for our variables. We will not know how many pizza slices or how many burritos, but we're going to use those variables to represent them. Let's translate some sentences. The first one, the number of pizza slices sold was 20 less than twice the number of burritos sold. We can translate that right now if you're reading it carefully. The number of pizza slices sold was P equals 20 less than twice the number of burritos sold. So twice the number of burritos minus 20, or 2b minus 20. This might be a thing you're starting to get used to, or it might be a thing you're still struggling with. That would probably be where everybody is right now. Keep working at it because it's the same structure every time. We also have a sentence involving the total. Pizza is $2.50 a slice, burritos are $3 a piece, and the cafeteria made a total of $358 that day. So, $2.50 for each pizza slice plus $3 for each burrito is equal to $358 total dollars. That's how you write a total number sentence. We've seen a lot of examples like this lately. You're going to keep seeing more and more of them. So keep getting used to them, keep playing with them. It'll be okay. Solving the system in part A is also going to be kind of tricky, but actually not too tough. Don't let those big numbers intimidate you. Everything works out pretty nicely in this problem. First of all, it's pretty clearly a substitution system since p is equal to 2b minus 20. So we are going to replace the p with 2b minus 20. And it'll look like this. 2.5 times 2b minus 20 plus 3b equals 358. And again, don't let these big numbers and decimals confuse you. They're all going to kind of work out on the way out. In fact, we're going to take 2.5 and multiply it by a couple of even numbers, which will make it nice whole numbers again. It'll make it 5b minus 50. That's 2.5 times 2 and 2.5 times 20. The rest stays the same, plus 3b equals 358. From here, it's pretty straightforward. 5b plus 3b is 8b minus 50 equals 358. Making sure to make my b's look kind of sharp so they don't look like 6s. If you add the 50 to both sides, it cancels out on the left, and you get 8b equals 408. And then finally, you divide by 8 on both sides, and believe it or not, that actually is a whole number, which actually is not too believable, because 400 divides by 8, and so does 8. So it's 51. 51 burritos. Of course, we also need to know how many pizza slices, but fortunately, one of our equations tells us exactly that information. The pizza slices is twice the number of burritos minus 20. Or in this case, 102 minus 20, which is 82. And you can use the calculator for those big numbers if you're struggling with that kind of stuff. But not a super difficult problem. Well, not a nice problem either, but we're going to move to the next page. Let's keep going. 463 is actually a pretty classic middle school problem, but you kind of have to know how to handle it. A local deli sells 4-inch subs sandwiches for $2.95, but they're going to sell a family-size sub that's 50 inches long, and they want to know how much to charge. What we're talking about here is what's called a unit rate. What we want to know is how many dollars it costs for 1 inch of sub, basically. The nice thing is that we know that a $2.95 sub is 4 inches long. So we can divide these things, and not only will the division work out, but the units will work out too. 295 divided by 4 is going to be the fun number 0.7375. But that number is not as important as the units it's attached to. That's how many dollars it takes for 1 inch of sub. And that's what we call the unit rate, or how much it takes for one of something to happen. It's that many dollars for 1 inch, and we want to know how many dollars it is for 50 inches. So 50 inches times 0.7375 dollars per inch. What's cool about this, and your science teacher will appreciate it too, is that the units actually cancel out. Inches cancels out with inches, and dollars are all that's left. So 50 times 0.7375 ends up being like $36.87 or something. But that's how many dollars you should charge based on the fact that it's this many dollars for every inch of sub. This is a relatively straightforward calculation, usually seen in a lot of middle school problems, but it kind of comes back. It's really important too. 464, we're going to use generic rectangles or not to multiply these things together. Hopefully we don't get interrupted by the bell. We'll see how long this takes us. Again, if you haven't used a generic rectangle in a while, it might be useful to set one up for at least problem A. We got x plus 2 and x minus 5 here. It's been a while for you with generic rectangles. The only reason why the rectangle works, it helps you to organize which ones you have and haven't done. You got to get every combination of these things here. So you got to have x times x, x squared. You got to have negative 5x. You got to have 2x, and you got to have negative 10. You got to have all 4. And then when you add them all together, you should combine together the x parts. So you're going to have x squared minus 3x minus 10. If you don't like the generic rectangle, which you might be getting a little too old for that stuff, what you can do is just kind of use arcs or something like that, as long as you have a way of remembering that you've got every possible combination. Y times y gives you y squared. Y times 3x gives you 3xy. 2x times y gives you 2xy. And 2x times 3x gives you 6x squared. Bet, as the kids say. Of course, the middle ones can combine together, so you get y squared plus 5xy plus 6x squared. Next question down below in question C. Again, kind of the same process here. I know, we're moving fast, but that's what we do. Negative 3xy for the first bit, plus 3y squared for the second bit. Careful here, negative 8 times negative x is plus 8x, and negative 8 times y is minus 8y. None of these are like terms, so we're done. And on question D, one more time. X times x, x squared. X times 3y, 3xy. Minus 3y times x is minus 3xy, and minus 3y times positive 3y is minus 9y squared. Careful on that 9 there, 3 times 3. What you might notice here is that the middle terms actually cancel out. Positive 3xy, negative 3xy. So the final answer is x squared minus 9y squared. And then down below, we're describing the association, a thing we haven't done in a while, but that's all we're doing here. How would you describe the association of this scatter plot? Remember, there's kind of 3 words we got to choose here. I would describe this as a curved scatter plot, by the way, not a straight line. I don't know if you see it or not, but I definitely see a curve in there, not a straight line. So I would call this non-linear. I would call it moderate. I don't think it's very strong because the dots are pretty well scattered around the line. And I think it's also negative because it's heading down. And then one more easy question to answer, question B. Cheetah Motors has come up with a super lightweight sports utility vehicle that weighs 2,800 pounds. What does the model predict the fuel efficiency will be? Well, here's the weight in thousands of pounds down here. 2,800 would probably be somewhere in this vicinity right there. So if we trace that up to the line and go off to the side, thanks guys, we'll get about 24 or 25 or so miles per gallon, because that's the unit there on the left side. So I think the final answer here is about 24 miles per gallon. Namaste. Thanks for being here with us today. I'll see you guys in the next video.